There are two methods of calculating the frequencies and mode shapes in StatPro. The one is called Rayleigh method, and the other one is called Eigen method. So in Rayleigh's method, we use a command called calculate Rayleigh frequency. And in Eigen method, we use a command called model calculation requester. So in the Eigen method, the command is model calculation requester. So these two are the commands for calculating the frequencies, natural frequencies in StatPro for any structure. So whenever we are modeling some structures, frame structures, or with plate elements, then we can calculate the natural frequency of the model by using either Rayleigh method or by Eigen method. So we will see in detail how these two methods will work. So first one is the Rayleigh method. Rayleigh method, it's a simple method. You can say it's an approximate method which gives only a single frequency of the structure. That is why it is called, it's a one iteration approximate method from which single frequency is obtained. And in this method, the display shape of the model is used for obtaining the frequency of the structure. So, like I earlier mentioned, we need to use the command calculate Rayleigh frequency in your model for calculating the fundamental frequency of the structure. So, what we will do, we will be having a load case here, and then after inputting all your loads in the structure, we need to mention calculate Rayleigh. So, this will give you the fundamental frequency of the structure. We will see by in a model how it works. So we'll go to a stat model. So this is one of the stat model of a 3D frame. So we have modeled the elements, then supports, and applied the loads also. And the loads are applied like this. You can see the loads applied in X direction here. Four types of loads are applied. So what we will do, you have to go to the command file. By graphical method, you cannot input the release method command here. So you need to go to the editor file, and then there you have to give the input. So just type calculate. So once you start typing that calculate Rayleigh, then this all the command related to those letters will be displayed here. So here you can see calculate Rayleigh, and the description is mentioned here. This command may be used to calculate the Rayleigh method approximate frequency of the structure for vibration corresponding to the general direction of deflection generated by the load case that proceeds this command. So once you double click here, the command automatically comes here. So calculate Rayleigh, that much is sufficient. So in your editor file, command file, you give the input calculate Rayleigh. If you write here after a particular load case, and then followed by perform analysis, then when you are running the analysis, the program will calculate the fundamental frequency of the structure. In this case, please note you will get only one frequency of the structure. That will be based on the deflection. Whatever the loadings which you are applied here, the structure will deflect in a particular manner. So based on that deflected shape, the program will calculate the fundamental frequency of the structure. So let's run this model and see how it works. So I'm just running it. So I completed the running, the analysis is completed now. You can go to the output file to see the results. See the output file. Here you will get the results in this manner. See, Rayleigh's frequency for the loading 111.34. So this is your fundamental mode of frequency here, and the maximum deflections in inch also is mentioned here. So please remember this value 111.34. Now we compare this value by the other method, eigen method also. So in this, the command is very simple. Use this command, calculate Rayleigh frequency. So once you use this command, we'll get the fundamental frequency for this structure by an approximate method in Rayleigh's method. So this is the first method. Now we will see the second method. So let us go back to the slide. So second method is eigen method. For the eigen solution method, the user is required to specify all the masses in the model along with the directions they are capable of vibrating in. That means we will take this structure, this model. So you see the loads applied are all are in x direction for this Rayleigh's method, right? So when we want to go with the eigen method, you should apply all these loads in all the three directions, means x direction, y direction, and z direction. So what you can do, you can just, okay, I will open the other model where I have edited those load cases. So in the loading, what I did, I applied all that same load I applied in x direction, y direction, and z direction. So this is mandatory to get the correct results when you are doing eigen method. So whatever loads applied in the structure, the same load you should apply in all the three directions for getting the right results when you are doing eigen method. So that is what it says. For eigen solution method, the user is required to specify all the masses in the model along with the directions they are capable of vibrating in. So any point or any node if you take, that node is capable to vibrate in all the three directions. So your load also you should apply in all those three directions. That is what it means. And if this data correctly provided, the program extract as many modes as the user requests. The default value is 6. That means when you are giving the command for calculating the eigen method, you will get first 6 modes of vibration. You will get first 6 frequencies of the structure and the first 6 mode shapes. In case if the structure having more mode shapes or more number of modes, you can give another command and you'll get more number of modes that we will see in the example here. So the command we need to use for eigenvalue method is model calculation requested. So you need to just type in the editor file model calculation requested. So like earlier we have seen for the Rayleigh's method, we have written calculate Rayleigh. Similar way, for eigen method, you need to write model calculation requested and then followed by perform analysis. So we'll see that example. So what we did, the earlier one, the load was only in one direction, x direction. Same load we applied in x direction, y direction, and z direction. So that is what we done here. So afterwards, you need to go to the command file, editor file. You need to just type model calculation requested. Same way, you start typing that word MODAL model calculation. So the list will come, and here you can see the command may be used to obtain a full scale eigensolution to calculate relevant frequencies and mode shapes. It should not be entered if this case or any other case is a time load or response spectrum case. So whenever you are using a time load or response spectrum case, this will not work. Eigenvalue a model calculation requested command will not work there. So if it is a not if it is a that load case is not a response spectrum method and it's a not a time load, then model calculation command will work. That is what this sentence means. So just double click here, model calculation. That command will come here. So this is sufficient for to run the analysis and then perform analysis. So we'll just see what will be the results we will be getting. So go to analysis and design, then run analysis. So you can go to the output file. You can view the output file. So here you get the eigen solution. And we see the first fundamental frequency. The first frequency is 111.236. But in the eigen solution, you'll get the more number of more modes you'll get. But in you remember the earlier, the first one, the release frequency method, it will calculate only first mode of vibration. You'll get only the first mode frequency in the first mode. But here you'll be able to get more number of modes and the frequencies in other modes also. So you can just in the post processing mode, you can able to view how the structure is vibrating or what shape, the mode shapes you can able to visualize here. So here there are, we calculated around 24 modes here. So you can go to the animation and then select this mode and then apply. Okay. So this scale you need to reduce. Select. So this is how the structure vibrates in the first mode, and you can see second mode. So first and second mode, you can see one was in the x direction, the other was in the z direction. So third will be a torsional mode. So you can see the reflected shape, how the third mode vibrates. Similar way, you can see all the other modes of vibration from the structure. In general, by default, you will get only 6 mode shapes only. But in this stat model, I given 24 modes. So that command how to give, you will just see. For that, go to analytical mode and then utilities, command file. See this command, cutoff mode shape 24. So by using this command, I'm controlling the number of mode shapes which I require while running the analysis. So in case I'm making this say 10 and I'm running this analysis. I'm going to post processing mode. See, now I'll get only first 10 mode shapes of the structure. So again, you can see the animation. If you want, you can see the animation. First mode, second mode, third mode, sixth mode, or all these modes of different modes of vibration will be able to see. Similarly, you can also see the mode shapes using table format also. You'll get it from here. And the frequency table is in the top portion here. So you can see first mode, the frequency is 111.236. Almost it is matching with the Rayleigh's method. Frequency which you are calculated using Rayleigh's method. And second mode 115, third 137, like that it goes on. So you need to remember that the first mode will be the fundamental frequency of the structure. All others are natural frequency. The first mode will be the fundamental frequency of the structure. So, these are the two methods of calculating the mode shapes and frequencies of the structure. In Rayleigh's method, it's an approximate method. It is calculated using the deflected shape of the structure. It's a non-iterative method, and it uses the command for calculating the Rayleigh's frequency is calculate Rayleigh frequency, and the second one is eigen method. And when you are using eigen method, you need to put a command model calculation requested. That is a command which you need to use. This one, model calculation requested. The only thing, remember, when you are using Rayleigh's method, you will get only one frequency of the structure. You will not get any mode shape or anything. You will get only frequency. The fundamental frequency of the structure you will get. And when you are using eigen method, you will get different. Maybe as a default, you will get first 6 nodes of structure you will get, and first 6 frequencies corresponding to that mode shapes you will get. And if you use the command model cutoff mode shape command from here, analysis miscellaneous commands, there is a command called cutoff mode shape. So if you change this cutoff mode shape commands to say 10 or 20 or whatever the value which you are required, so the program will calculate that much number of mode shapes in your program. Only thing you need to remember, when you are using eigen methods, you should apply the loads in all the 3 directions. Then only you will get the exact mode shapes of the structure. Okay, thank you.